Okay, if you have an atom with a positive nucleus and an electron that is orbiting, in order to knock this electron or free this electron from the pole of positive charge, we have a large negative potential energy between the two. We have to add enough energy to the electron to bring this essentially to a distance that is an infinite amount away, which means your electrical potential energy will drop to zero. Or something really small, which means your work has to be enough added here so that this can get this an infinite distance away. Now, what we're going to talk about is the photoelectric effect. Basically, what's going to go on in this simulation is that you have a specific photon of a specific wavelength. Closer to UV, we'll have shorter wavelengths. Closer to IR, we'll have infrared light will have higher wavelengths. In a cathode, think of a cathode as a fluorescent light bulb. It's empty. It's evacuated. There's no air in there. In this case, this cathode has specifically sodium on one of the cathodes. So the light comes in, excites the electrons in the sodium, and we'll observe what happens. Okay, so if I turn the light on, the intensity goes from, let's just say 7%. You can see that there's an electron that gets excited and travels across the tube to the anode. Sorry, to the cathode. So as you increase the intensity here, we see more and more electrons getting excited, all moving at various rates. My computer's super slow, so they're like crawling across the screen, across to the other side. So essentially you have all these photons colliding with the sodium, exciting the sodium's electrons, getting past their work function, giving them enough energy to excite themselves across the cathode. Okay, now if I change the frequency here, okay, so I'm making the wavelength longer, which means I'm making the energy of the light smaller and the frequency of light smaller. We see ultimately, as I go to red, that this stops occurring. If I bring it down to the other end of the spectrum, to UV light, and you can see on the graph, as you increase the frequency, you will end up getting electrons flying off that. So the higher the frequency light, essentially this would make sense, the electron absorbs